a butterfly, a dart, and a bottle of beer. Okay, if you don't get it at the end, there's some help. All right, so my objective of the talk today is to get each and every one of you to try Flutter. Okay, I think it's a great development environment for mobile, and I want you to try it. I'm going to run you through my experience in terms of building mobile apps. Some time spent on a framework called Corona. There are a lot of similarities between Corona and Flutter. Then we'll look at Flutter on mobile, and lastly we'll have a quick look at Flutter on the web. Okay. My approach today is to show you lots of demos. Okay, I want to show you how the stuff works. I want to show you what I've built with it. So it's very interactive. So unfortunately, that's also going to mean from a housekeeping perspective, I need to switch between the presentation machine and the development machine. So there'll be some breaks in between that. Where did my mobile development journey start? It was that Nokia phone. Remember the one you had in your pocket about 10 or 12 years ago? No, not the one with the green screen and the no writing on it, the one that had a color display. Those were one of the first mobile phones where actually anybody could download the J2ME developer toolkit and start to build apps for the phone. Okay, so it was around this time that I started to think, well, let me try and build a mobile app for the Nokia phone. So then the next thing was, what app do you build? Okay, you guys have seen in the hall outside a couple of cool apps that have been built. I thought about what would I want to build on a Nokia phone. Remember, it was about 2006, 2007, somewhere around there. So I went back to, what did I play as a child? Anybody know this console? Okay, no, it's an Intellivision console. It's a TV games console. Okay, I had one of these, all right? And the game I liked to play on this was called Utopia. All right, in those days, the artwork on the cover was a lot more impressive than the artwork in the actual game. Okay, so here you go. This is what the game looked like. Okay, two-player game on the TV. Each player has an island. You can plant some crops. You can plant houses and hospitals. And then if you're bored, you can go fishing with your little red fishing boat. And every now and then, the nasty little black pirate boat comes and destroys your fishing boat. And if that's not bad enough, the hurricane comes and destroys your crops. Okay, so nice little game in terms of to be able to put onto a mobile phone. First problem with a Nokia phone. How big is the TV screen compared to the screen on the Nokia phone? Nokia phone's tiny. So in order to implement something like this, I had to implement scrolling. Okay, next problem. On a TV screen, you can see both islands at the same time. On the phone, you can't really. Okay, so I went down the road a bit with this, but it wasn't really going anywhere fast. So I kind of abandoned my Nokia phone development. The other challenge with the Nokia phone is the workflow cycle in terms of making a small change and getting it to compile and deploy to the device. At the time, that took about 5 minutes. Okay, so from you making a small change, you had to build and compile, then you had to deploy it to the actual device over a serial cable, and so the development cycle was 5 minutes. So making small changes was very slow and very cumbersome to actually build apps in this environment. Okay, so I abandoned that. Things changed in the meanwhile. In June of 2007, Apple launched the iPhone. But many of you may not remember that the iPhone did not launch with apps. The iPhone had no apps. Steve Jobs famously said that all you need is a web browser. Okay? However, a year later, they launched the App Store in July of 2008. Okay? And then another thing happened. in April of 2010, the iPad launched. And this is where my interest in development started again in terms of building for a mobile app. So, in this world, things were a lot more interesting. Okay, so I thought again about how do I build Utopia in iOS. But then, like with startups often pivot at a point. And so one day I stopped worrying about trying to make Utopia work. I thought, let me just try something simple. And so there was born the clock app. Okay? And that's what you're going to see a lot of today, because I built the clock app. All right, how did I build this app? I used a framework called Corona Labs. This was something that was released in 2011. At the time, I had the option of either starting in Objective-C and learning Objective-C and writing it in native, but I actually wanted to build a game. So having a games engine was far more simple. So Corona, as a framework, as an engine, allowed you to build for iOS and Android out of the box. It used a scripting language called Lua. If any of you have written any games, even the general platforms, generally the scripting language that the games industry uses is Lua. So it's a standard language that has elements that was reasonably easy to learn out of the box. So, framework that does that. The whole principle of Corona is the fact that it doesn't start with any capabilities. You get a blank screen, a blank canvas, and you paint on the canvas what you want. So you can design. And at the time, performance was everything. In terms of the mobile phones, didn't have the fancy graphics processors they have in them today. Just trying to do simple graphics and get them to animate was actually quite challenging. So that's why at the time it was quite important to have performant library. What Corona provided you with was an actual library to build controls on top of the Corona library that looked and felt like iOS and Android controls. Okay, so it gave you that capability so that you could build apps that looked and felt real. What it also gave you that was very important compared with what the Nokia platform had, where the development workflow lifecycle was 5 minutes, remember? This one gave it to you in 11 seconds. So if you made a change, you could, on the equipment of the day, see that change within 11 seconds. And that creates an environment where you can rapidly prototype and rapidly build up what you want to do. Also came with a good physics engine, but that wasn't really that interesting to me. And at the time, it actually cost you $99 a year if you wanted to deploy your app to the store. Okay, so in preparing for this talk, I thought, well, let me dig up my old Corona code and see if it's possible to get this stuff to run. And so the first thing I had to do was find out whether Corona was actually still around. And amazingly enough, it was, but they've actually open sourced, and so now the platform is available for free. So let's have a look at my 8-year-old Corona app. Right, so here's the code. All the code in Lua. So the whole app to build the clock is just under 500 lines of code. I installed the Corona framework, I found the code, and I figured out that they'd introduced a new graphics library since I'd built it. So one of the changes that I had to implement was the capability to have graphics compatibility set to 1, which is the old legacy graphics. And then the other thing that had happened is the analytics engine that I'd used for the app had actually ceased to exist, so I had to remove all the elements of the analytics engine. But apart from that, it took me about 20 minutes, and my app was up and running. Okay, there it is running. Took me 20 minutes to get it to that point. All right, now to demonstrate how quickly that developer lifecycle is in Corona with today's equipment, I'm just going to dive in over here and look at changing the color of the hour hand. Did you see the hour hand change? Okay, so with today's technology, using Visual Studio Code as an editor, you're able to literally do it instantly. So the emulator they're using in terms of for Corona is a custom-built emulator, so it's not the one that Apple ships. And so it's integrated, and so it's incredibly fast. So even though the scripting language is quite dated, and most of the things are no longer supported because the device is effectively an Apple iPhone 5, I think, something like that. It's incredibly fast to develop over here. Now, the thing is, I wanted to take this app to the App Store. So I actually spent quite a bit of time polishing the app and making sure that the app was at a quality that Apple would accept it into the App Store. And that actually ended up taking quite a bit of time, because originally my idea was to build the game, to basically pivot and spend about a week on trying a utility app and then get back to building the game. But I ended up spending a lot of time actually on fine-tuning, because there's certain elements that you need to work quite hard on. And one of those is the ability to actually rotate the device, and smoothly, if you're doing it with a physical device, you'll see it actually smoothly rotates and then also repositions the digital clock. So those are all nuance elements. And it's while I was doing this that I actually started to struggle quite a bit with the scripting language, because the scripting language doesn't have much structure to it, and minor typos can take you hours to actually find why you've got a small nuisance thing that's just tripping you up. So that was the one element. The other element is what typically happens if you're building an app on a watch, on a phone. What happens after 30 seconds? The screen locker comes on. Okay. So in order to build a clock app, you want to actually have it that'll be on for longer. So there's a way you can override it in the operating system, but you want it to be a setting. So this is where I started to use the library that allows you to have controls that look like iOS. I think this was 3 or 4 at the time. And so in Corona, you had this ability to add the controls. But actually, this is where it starts to actually become very hard. And the ability to start to implement more of those controls, this environment, and the scripting language just became really, really hard. And so I decided it was time to move off Corona and try to move onto Xcode itself. So I started again from scratch with the app and started building the app in Xcode in Objective-C. And the Objective-C version, obviously you've got this visual view. This is the iPad version. And the part that's easy to do in Objective-C is the actual config screen. So to have a config screen with always on and status bar and stuff like that, really simple to do, not hard at all. Okay. The code is also much nicer and more structured in terms of in Objective-C. I don't expect you to read any of it. There's a lot of it. Okay, so I focused on, in Corona, you saw the file was about 500 lines of code. In Objective-C, there's a lot more code. So there's the main view controller. I had the ability to have the clock face, and then also because it's object-based code, you could have a class for each of the hands. So it allows for all of that, and it allows for a lot more structure, but there's a lot of code to maintain. All right. And also, this environment. So, question for the audience. How long do you think it took me to get this one up and running? Right, the answer is I don't know, because I spent 20 minutes on it, okay, and if you look carefully at the top corner, it's still got some fatal errors, and this is the actual challenge when you're using the platforms of iOS and Android. They move so rapidly and they don't provide backward compatibility for a long time. So 8 years down the line, this is Xcode 11. This was originally written in Xcode 4. All right, and probably the structure of the project file is no longer adequately correct. So the only way to actually get this up and running is to start a new project and to start to slowly inject all the pieces of the code. So that was my experience in terms of Corona and using Objective-C. So I've taken you through the Xcode. So this app is not fake. I had this app in the App Store for about 2 years. In 2012, these are the stats for the year. Okay, 2,500 people downloaded a clock app on their phones and on their iPads. And you'll see it's about 5 to 10 people a day downloaded a clock app. So I learned quite a bit in doing this. The versions at the bottom, so you'll see the 1.2 is actually the Corona version of the app, and the 2 is the Objective-C iOS version of the app. Surprisingly enough, I had more sales in the Corona version than I did in the Xcode version. Okay, but trying to keep this up to date. So iOS continuously updates in terms of versions of the operating system. And Objective-C continuously changes as a language, and there's obviously Swift that came now. But trying to keep up with all those changes meant that I was actually spending a huge amount of time just perpetuating what I already had. And so this is one of the learnings in terms of if you're doing apps, you have to continuously be on top of them just to keep them at the level that they're at. Eventually in 2013, I withdrew the app from the App Store, so it hasn't been there for a while. Right, so let's move on to Flutter. So the approach in Flutter is very similar to the approach that Corona had in 2011. Just now it's backed by Google, and it's a major initiative to really provide you simply with a clear canvas that you can paint on, all right? You don't have any of the underlying controls that each of the platform providers provide you with. So the first thing you need to become familiar with if you want to do anything with Flutter is Flutter uses a programming language called Dart. Okay, Google also invented Dart. So Dart was created in about 2013. The first version of Dart came out, and towards the end of 2018, the second version of Dart came out. It's quite a rich language. It's quite elegant in terms of how it allows you to code with efficiency. And Google chose it for Flutter because it has a characteristic in terms of that it allows for ahead of time compiling. So that's what your traditional C++ compiler does in terms of that it compiles your whole program into object code that runs natively on the device. But it also allows for just-in-time compiling. So remember that rapid workflow that I was talking about? So it allows you to do some of the base work and then do a big compile, but then if you're just trying to do the tweaking of the UI, it actually allows you to do that in a very rapid prototyping way. And so that's one of the reasons why the Flutter team say they chose Dart as a language. Dart also allows them to have one language that provides you, that you code in for the UI as well as your program logic. So you don't have multiple languages that you need to learn. And the team from Google believe that Dart is easy to learn, but you'll have to figure that out for yourself. All right, so if you just want to play around with Dart, there's dartpad.dev on the web where you can put a program together. And so here I've just got a sample program. I assume most of you have been through the BBD assessment, and one of the questions that's typically in the BBD assessment is the Fibonacci series. So here's the answer in Dart. Some of you might spot also that this one doesn't cater for all the conditions that the BBD test caters for, but that's good. So the main program is just void main, and then you're able to print out the result of that. So you can play around with Dart, but literally it is a case of you need to actually spend some time getting familiar with Dart if you're going to want to be able to program in Flutter. Flutter is more complicated than Dart. All right, so moving on to Flutter itself. So what is Flutter? It's a platform as well as an API. It provides you with an environment to build high-performance, low-latency apps. So apps that look good, apps that are responsive, apps that are fast. Okay, that's what they're all about. They're native apps. They're running on the device itself. They're fast. Flutter supports iOS and Android at the moment, and as I said, built on Dart. Now, when I first started looking at Flutter, I was quite disappointed with the whole design element, because I looked at it and basically thought, well, Google have just found an easy way to run Android-like type looking apps on an iOS device, okay, because the material design is the design that Android uses. And the truth is, initially that was the case. But the team at Flutter has actually been working very hard to allow you for your app to create a custom material design for your particular app. So if you look at the successful apps that are on the App Store today, for Airbnb, Uber, and Netflix, they all have their own design language. They're not using iOS's design language or Android's design language. They have their own design language. And the whole bottom line is, in Flutter, you have the ability to build your own design language, and that's where material design comes in. If you need to use some of the operating system controls, the libraries are there for Cupertino and Android. They chose to call it Cupertino for the Apple controls. However, this is not as cleanly done as maybe they could have done. It doesn't detect automatically that you're on an iOS device or an Android device. You actually have to query and make sure that you understand what the underlying device is that you're operating on. The big feature is the hot reload. Okay, I'll show you that in a little while. It's a 2D optimized engine, so it's good for 2D apps. If you want to build 3D apps, Flutter's not for you. And lastly, on the point of compatibility, it's made for reasonably modern devices. So on Android, we're looking at Android 4.1, so that's Jelly Bean or newer, so any device from about 2012 or newer. On iOS, you're looking at iOS 8, so any device effectively from about 2014 or newer. So it's not for old legacy applications either. Then what does an app look like? So if you're building your classic shopping cart app, this is what it would look like. You can see the subtle differences between the arrows in terms of the back arrows. That's where it's using the proper iOS and proper Android controls. And so it's one code base trying to target both platforms. Right, how do you build a Flutter app? Everything in Flutter is a widget. Okay, so everything inherits from a widget and everything is a widget. So like in Java and C# where everything is an object, in Flutter everything's a widget. And effectively you have these tree graphs of your widgets, and you get two types of widgets, a stateful widget and a stateless widget. So a stateless widget just represents something on the screen, and a stateful widget is something that actually has state, like a scroll bar or something like that. And then you create hierarchies of these in order to build your actual application. The architecture of Flutter is as follows. If you want to, you can use the material and the Cupertino libraries if you want to have controls that look like the operating system, or you can just build your own widgets. Those widgets then sit on a rendering engine, and the rendering engine allows for the ability to do animations and to do the actual painting, as well as responding to gestures, so that's where the user interacts with your application. And all of that sits on a foundation, and that foundation sits on an engine that's written in C and C++, because remember, it's performant. Okay? And then for each specific platform that you're running on, there's an embedder. Now, I don't want to spend a huge amount of time on this or scare you, but this is what the definition of certain widgets look like. So the scaffold, for example, is the frame or the chrome around your actual application that sets up your basic application on the mobile phone. And then here I've got the example of if you want the text, so where I've got the digital element of the clock, that's the code you would need. So here is a bit of Flutter code, and the layout is quite strange because that is just one method called to scaffold. And typically you keep one parameter per line, and then you embed actual calls to things like text. So you've got the scaffold at the top, and then you configure all these things. That's why you need a modern editor like VS Code or something like that to match up all those brackets, because otherwise you're going to be in hell. All right, so just to show you there, the scaffold set up the app bar, the body, and the background color, and inside it, it called the actual text to set up the layout. So this is how you lay out your Flutter application. And this is where I say you need to be familiar with Dart to be able to be familiar with Flutter. All right, so let's look at a demo of Flutter. All right, so here I've got the emulator running here on the side. This is the actual iOS emulator. It's an iPhone XR. And I'll start the compiling running so long. Remember, it's ahead of time compiling, so that takes a bit of time. So over here, this is the main app. And just take note at the top over here, we include the library Flutter Material Dart. And then here's the main app. And then there are three actual classes that are defined in this app. Again, here the material Flutter. There's the piece of the scaffold that I showed you just now on the slide. And then in detail, the actual clock face to draw the clock. But in the meantime, the app has started up, and there it is on the right, up and running in Flutter. Same app that I built in Corona. Okay. So, to show you the workflow cycle, so let's change the color of the second hand from red to blue. All right, you see again, basically instant. Here it even tells you it took 279 milliseconds in order to do the just-in-time compile for that. And this is where Flutter is really fun. Once you have your actual structure of your application up and running, to interactively build the application really becomes an interaction rather than you're trying to think up the code and not seeing what the actual result is of what it is that you're building. So to change it back again, almost instant. Right, let's get the slides up. So that was just a quick appetizer in terms of Flutter to show you what it can do and how to get going. So you saw the hot reload capability, very quick to get that going, fast development, quick rendering, the ability to do cross-platform. I didn't show you the Android emulator over there. I was running it on iOS, but literally the same code. You fire up the Android emulator and you can run the exact same code. It's open source and free. You just download it and use it. Right. Flutter is, however, moving out of the mobile space and moving on to the web as well. So what they've done is they've taken the source code of Flutter and they've created what they call a code-compatible version that runs on the web. So this now allows you to take your exact same code, and so while the Flutter that you've seen on mobile is very much production-ready code and you can use it anywhere, the web is still experimental. Okay? So I played around with this to see what can we do in the web. So the architecture of the web is very similar in terms of that you have theming capabilities from the web. There are widgets, your widgets you define, and the rendering engine and the animation, the painting, and the gestures, all very much the same as it was in the mobile, and all of that effectively just runs on top of the browser. Okay? But the environment isn't quite yet as sophisticated as it was for mobile. And so you have to do a couple more things to actually get the web to work. So let's have a look at that quickly. So firstly, for the web, you have to unfortunately create a copy of your Dart code or your Flutter code in order to be able to do that. And then the thing that you need to change in the code is, why I pointed it out to you earlier, is you now include Flutter web material.dart. And then apart from that, I just needed to make a minor change to the code because the browser is a lot wider, has different dimensions to what the actual phone has. So I just needed to cater for that. And unfortunately, at the moment, Visual Studio Code doesn't yet support running the web version directly out of the browser. So you still have to run the actual web server on the command line. So I'll start that up over there. But as I say, the code is actually identical to the code that was running on the mobile phone. And there you see, same app running now in a browser. No extra work. Okay? So, and I want you to also take note of how concise the Flutter code is. Okay, so look at what we've got here. 20 lines of code in the main Dart, about 40 lines of code over there, and just under 80 lines of code to actually render the clock face. Okay, so this is highly efficient code that allows us to very clearly and in a very efficient way define the app that we're trying to build. All right? And the same story applies in terms of, so not all the libraries are yet supported in the web version. So you will have noticed that in the mobile version, maybe some of you picked up that I have a custom font there for the digital display of the clock at the bottom. The web version doesn't yet support that. And so that's not yet a capability that the web can do. And so there are other things. So if you're building a more complicated app, some of the libraries are not yet supported for the web, and some may never be. Okay, but your development cycle in terms of rapid workflow is the same with the web. So let's go for yellow today. Just the web from the first change takes slightly longer in order to make the change, but there you go, instant change to the app. Okay, is that impressive? So just in summary on the web, so the web allows you to reuse your existing code. You have to create a new project. You do still have to have a separate code base, but Flutter is moving towards the fact that they're going to integrate the code bases such that web will become a first-class citizen, in which case your one code base will be able to run on all those platforms. And this really, Flutter calls this a connected PWA. So in the use case, in terms of if you're talking about building a mobile app and having the scenario that people can use your mobile app through their browser, this is the perfect use case for it, because without any extra work, you get a PWA app out of the box. Okay, and so it really starts to make the scenario efficient in terms of PWA for those users who just quickly want to use your app, whereas those who actually are prepared to download your app from the App Store, they will download the full app. Okay, so in conclusion, did you all get it? Okay, wasn't hard. So Butterfly was the Flutter, Corona was the Corona framework, and Dart is the Dart language. Right, so Flutter allows you to build, it's ready to build apps on iOS and Android. Flutter gives you the rapid development cycle that you want in terms of with a hot reload capability. I found it was quite hard to actually get the framework of the app up and running, and there was quite a learning curve in terms of getting those basics into your app. But once you have the basics of the app running, to actually interactively design the app and build the app, that was a lot of fun. And that went very, very quickly. Okay? So you also saw that Flutter makes use of a lot of named parameters. So you need to start to become comfortable with named parameters and understand how they work and understand exactly how the whole Flutter API is structured. So the question, would we use it in BBD for development? The answer is definitely. Okay? Is it ready for enterprise development? For sure. I think our customers are going to start asking for this soon. So this is something that we need to get familiar with. From the web perspective, the web is still not quite there. So it's not yet ready, but it will be. From what you need to learn perspective, if you're good at CSS styling and HTML styling, unfortunately you're going to need to learn Flutter's material design and how Flutter does styling, so that's new work that you have to do. From a code perspective, it's one code base, so there's no separation between the UI code and the actual code for the programming. And I've done this as part of my drive for continuous learning in BBD to get up to speed with Flutter and the Dart language. So I encourage you to try the same. And lastly, my call to action. Okay? Go try it now. Continue learning and build your own Flutter app. Thank you, everyone. Enjoy the rest of Escape.